I have 1000 samples in my dataset. That's the total number of data points I'm working with. Pretty big dataset. This refers to the first of two separate train test splits that I'm creating using StratifiedShuffleSplit. Remember, I'm using StratifiedShuffleSplit, so class proportions will be roughly similar in training and testing sets. This is the second of the two train test splits. It's independent from split 1, but again, it follows the principle of stratified sampling to maintain the class distribution. Since I specified _test_size equals 0.2 which means 20%, approximately 200 samples, 20% of 1000, will end up in each test set. Split 1 and split 2 means, approximately. Because I'm using stratified sampling, the proportion of classes A, B, and C will be roughly the same in both training and testing sets for both splits. That's the beauty of stratified sampling. I'll still have a total of 1000 samples in each of my train test splits. I'm just dividing those 1000 samples into training and testing portions. No, I can't absolutely guarantee perfectly equal class representation in every split. There is some randomness involved in the shuffling process of stratified shuffle split, so minor variations might occur. The aim is to keep things as close to even as possible though. N_splits equals 2 means I will get 2 train test splits. Test_size equals 0.2 means each test set will be approximately 20% of the data. I'll use this to show how the stratified shuffle split function in scikit-learn works. It's a way to split data while keeping the proportions of different groups, classes, the same in both the training and testing parts. We have a dataset with 1000 samples in total. Think of these as individual data points that we want to split into training and testing sets. Within the dataset, 300 samples belong to Class A. This is one of the 3 categories that the samples are divided into. Similarly, 400 samples belong to Class B. We want to make sure that when we split the data, the ratio of Class B remains similar in each split. And finally, 300 samples belong to Class C. The goal is to have a fair representation of each class in both training and testing sets. I use the stratified shuffle split function. The N_splits equals 2 part tells it to create 2 separate train test splits. The test_size which is 0.2 in the original question, determines the percentage of data used for testing, in this case, 20%. This is the first split that stratified shuffle split generates. It divides the data into training and testing sets. This is the second split that stratified shuffle split creates. Again, the data is divided into training and testing parts, maintaining approximately the same class proportions. In each split, 800 samples are used for training the model. This is 80% of the total dataset, 1000 samples. In each split, 200 samples are used to test the model's performance. This represents the remaining 20% of the dataset. The magic of stratified shuffle split it makes sure that the different classes, A, B, and C, are represented in a similar proportion in both the training and testing sets of each split. It won't be exactly perfect, but it will be close. I'm tackling a question about stratified shuffle split, a scikit-learn function used for creating train test splits while maintaining class proportions. I'm working with a dataset containing 1000 data points. Class A has 300 samples. Class B consists of 400 samples. And Class C also has 300 samples. I'll create 2 separate train test splits using nsplits equals 2. In each split, 20% of the data, that is, 0.2 * 1000 equals 200 samples, will be allocated to the test set. I've set testsize to 0.2. Because I've specified testsize equals 0.2, each test set will contain approximately 200 samples, 20% of the total dataset. Because of stratified sampling, the ratio of classes A, B, and C will be roughly the same in both the training and testing sets of each split. Each split will maintain the total number of samples, 1000. Although StratifiedShuffleSplit aims for equal class representation, it doesn't guarantee it perfectly because of the random shuffling involved. There will be minor variations. This question tests your understanding of how StratifiedShuffleSplit works in scikit-learn. It focuses on how this function splits data while keeping the proportions of different classes similar in both training and testing sets. We have a dataset with 1,000 samples. These samples are divided into 3 classes, A, B, and C. Class A has 300 samples, Class B has 400, and Class C has 300. I'm setting the number of splits to 2. This means StratifiedShuffleSplit will create 2 independent train test splits of the data. I'm setting the test size to 0.2, or 20%. This means that for each of the 2 splits, 20% of the data will be used as a test set, and the remaining 80% will be used for training. In this case, that's 200 samples. 0.2 * 1000 equals 200 in each test set. This is the actual quiz question. It asks you to identify which statements are true about the train test splits that StratifiedShuffleSplit creates given the specified parameters. I need to consider how the chosen parameters and the nature of stratified sampling influence the resulting splits. This question tests your understanding of how StratifiedShuffleSplit works in scikit-learn. I'm asking you to think about how it splits data while keeping the proportions of different groups, classes, consistent. I'm giving you a dataset with 1,000 samples to work with. This is the total number of data points I am using for the experiment. Of those 1,000 samples, 300 belong to Class A. I mention this to give you information about distribution of classes in the dataset. 400 samples fall under Class B. This further explains the class distribution in my dataset. Another 300 samples are in Class C. I am specifying class distribution to help you understand the context of stratified sampling. I set the number of splits to 2 using NSPLITS parameter. This means I want 2 separate train test splits of my data. I also set the test set size to 20% of the total data using the TESTSIZE parameter. That's 20% of 1,000, which gives me 200 samples in each test set. This statement checks if you understand that my test size parameter, 0.2, will give approximately 200 samples in each test set. This statement asks if you know that StratifiedShuffleSplit aims to keep the proportion of each class similar across the train and test sets. This statement checks if you understand that the total number of samples stays the same. The total dataset is still 1,000 samples. This statement checks whether you know that StratifiedShuffleSplit tries its best to balance class proportions, but it can't guarantee perfectly equal representation due to the random shuffling it does. I'm analyzing a question about stratified shuffle split, a technique used to create training and testing datasets while preserving class proportions. This is important for ensuring fairness and accuracy in machine learning models. I have a dataset with 1,000 samples, distributed across 3 classes, A, B, and C, with 300, 400, and 300 samples respectively. This class distribution is key to understanding how stratified shuffle split works. I'm setting n_splits to 2, meaning I want the algorithm to create 2 separate training and testing sets. I'm setting test_size to 0.2, which means each testing set will consist of 20% of the total dataset, or 200 samples, 20% of 1,000. Because test_size is 0.2 and I have 1,000 samples, I predict each testing set will have approximately 200 samples. Stratified shuffle split aims to maintain the proportion of classes A, B, and C in both the training and testing sets of each split. That is, the ratio of classes will be roughly the same as in the original data. Each split, training plus testing, will have all 1,000 samples from the original dataset, simply divided differently. While stratified shuffle split tries its best to maintain the class proportions, it's not guaranteed to create perfectly equal representations because of the random sampling involved. There might be minor variations. This question tests your understanding of how scikit-learn's stratified shuffle split works. We'll examine how it splits data while keeping the proportions of different classes balanced. It's all about making sure your test and training sets accurately reflect the real-world data distribution. We're working with a dataset that contains 1,000 data points, representing various items or observations. Within that dataset, I see 300 samples belong to Class A, and 400 samples belong to Class B. Finally, another 300 samples are classified as Class C, so I have a nice distribution of data across 3 classes. I'm setting n_splits to 2, which means I want StratifiedShuffleSplit to generate 2 distinct training and testing sets for me. Think of it as creating 2 independent experiments. Setting test_size to 0.2, or 20%, means that in each of those 2 splits, 20% of the data will be used for testing, and the remaining 80% will be for training. That's 200 samples for testing in each split, 20% of 1,000. Because of the 20% test size, I expect each test set to contain roughly 200 samples. That's what the test_size parameter tells me to expect. Magic of stratified shuffle split. I want the proportion of classes A, B, and C to remain similar in both the training and testing sets. This ensures my models aren't biased toward particular classes. The total number of samples in each of these test splits remains 1,000. I'm simply dividing the data into training and testing portions. While stratified shuffle split tries its best to balance classes, I can't expect perfectly equal representation in each split. There will be some small variations because of the random shuffling. It's approximately equal, not exactly equal.